Alright, section 6.4 is all about the triangle midsegment theorem. So let's get familiar with some vocabulary. The midsegment of a triangle is a segment connecting the midpoints of the sides of a triangle. Every triangle has three midsegments, which form the midsegment triangle, triangle MNP. So in other words, M, N, and P are midpoints of segment AB, AC, and BC respectively. All right, let's take a look at example 1 using the mid-segments in the coordinate plane. In triangle JKL, we want to show that the midsegment MN is parallel to JL and that MN is equal half the length of JL. Alright, so in the figure for example 1, midsegment MN can be called the midsegment opposite segment JL. So our first step is to find the coordinates of M and N by finding the midpoints of segment JK and segment KL. Okay, so we plug in the coordinates of J and K to get midpoint M located at -4, 3, and then we plug in the coordinates of K and L into the midpoint in order to get midpoint N, which is located at 0, 2. Step 2, find and compare the slopes of segment MN and segment JL. So we plug in our coordinates to find the slope of MN, and we find that the slope of segment MN is -1/4. We plug in our coordinates for J and L into the slope formula and find that the slope is -1/4. So since the slopes are the same, we can conclude that segment MN is parallel to segment JL. So in other words, our midsegment MN is parallel to its opposite side, JL. Our third step is to find and compare the lengths of MN to JL, and that involves the distance formula. So we plug in all our coordinate values, so coordinates of M and N plug into the distance formula to find that the length of MN is square root of 17. Then we plug in coordinates for J and L into the distance formula, simplify completely the radical, and we get 2 times the square root of 17. So we can see that MN is half the length of JL. So because square root of 17 is equal to half of 2 square root of 17, we can conclude that MN is equal to half the length of JL. Alright, now you try these on your own. Use the graph of triangle ABC. For number 1, in triangle ABC, show that midsegment DE is parallel to AC and that DE equals half the length of AC. And then step 2, find the coordinates of the endpoints of midsegment EF, which is opposite of segment AB. Show that EF is parallel to AB and that EF equals half the length of AB. So pause the video now and complete numbers 1 and 2 on your own. Then unpause to reveal the answers. Alright, here's all the work to support your answers to numbers 1 and 2. Our first step was to find, for number 1, was to find the slopes. We found that the slopes were the same, so because the slopes were equal, we can conclude that DE is parallel to AC, because parallel lines have equal slopes. Then we find the length of DE and the length of AC using the distance formula. We found that AC was twice the length of DE. So we can conclude that DE is half the length of AC. And for number 2, our first step was to find the midpoint of segment AC, which is located at 3, -3. And then the midpoint of BC, which is located at 2, 2. So the midpoint F is at 3, -3. Midpoint E is at 2, 2. The slope of segment EF came out to be -5. The slope of segment AB came out to be -5. So therefore, those two segments are parallel. Found the length of AB to be 2 square root of 26 using the distance formula. And EF came out to be square root of 26. which is half the length of AB. So we can conclude that EF is half the length of AB. Okay, so these properties lead us to the midsegment theorem, which states that a segment connecting the two sides of a triangle is parallel to the third side and half the length of the third side. So we can summarize that to an implied statement that reads, midsegment of a triangle implies connection between midpoint of two sides of a triangle, parallel to the third side, and half the length of the third side. So in our diagram here, we can say that segment DE is a midsegment of triangle ABC. Therefore, segment DE is parallel to segment AC, and segment DE is half the length of AC. Alright, so let's use this triangle midsegment theorem to try example 3, where we have triangles are used for strength in roof trusses. In the diagram, segment UV and VW are midsegments, so UV and VW are midsegments of triangle RST. So find the length of UV and the length of RS. So first step is to sketch the picture with the important pieces. So we want to know that segment UV and VW are midsegments, and we want to find that the length of UV and the length of RS. All right, we know that the length of UV, which is a midsegment, so UV is a midsegment, we know that this midsegment is half the length of RT. So we first set up an equation with that information. Then we substitute, we know, we know that the length of RT is 90, so we substitute 90 for RT. We work this out and we get UV is equal to 45 inches. Next, since we know that RS is the side of a triangle and that VW is a midsegment, we can say that twice the length of VW is equal to RS. So we substitute 57 for VW, and we get that RS is equal to 114 inches. So here we have two different examples, one in which we use the midsegment to be half, this one, we use the midsegment to be equal to half the length of the side that it is opposite of. And then in our second equation, we used that the side opposite is equal to twice the length of the midsegment. So you can set up in either format and get the same answer. All right, now you try extra example number 3 to practice using the properties of a midsegment theorem. So here we have segment DE is a midsegment of triangle ABC, and find the length of AC if you're given in the diagram that the length of AE is 4.8. So pause the video, take a minute, work this out, and then unpause to reveal your answer. All right, did you get AC equals 9.6? Well, if you didn't, think about this. Since segment DE is a midsegment, that makes E a midpoint of segment AC. So therefore, AE is congruent to EC. So if that's true, we can say that AC equals AE plus EC. Since AE is 4.8, we add another congruent 4.8 to get a total of 9.6. All right, let's take a look at a new example. In the kaleidoscope image, segment AE is congruent to BE. AD is congruent to CD. We want to show that CB is parallel to DE. Well, we start with what we're given. So because segment AE is congruent to BE and AD is congruent to CD, we can then say that E is the midpoint of segment AB and D is the midpoint of segment AC by definition of midpoint. then segment DE is a midsegment of triangle ABC by the definition, and segment CB is parallel to segment DE by the triangle midsegment theorem. All right, let's take a look at our final example. Pear Street intersects Cherry Street and Peach Street at their midpoints. Your home is at point P. You leave your home and jog down Cherry Street to Plum Street, over Plum Street to Peach Street, up Peach Street to Pear Street, over Pear Street to Cherry Street, and then back home up Cherry Street. About how many miles do you jog? All right, first we need to understand the problem. You know the distances from your home to Plum Street along Peach Street, so we have 2.25 miles. And then from Peach Street to Cherry Street along Plum Street, which is 1.4 miles. And from Pear Street to your home along Cherry Street, which is 1.3 miles. So you need to find the other distances on your route, then find the total number of miles you jog. So we need to make a plan. So by definition, you know that Pear Street is a mid-segment of the triangle formed by the other three streets. So use the triangle mid-segment theorem to find the length of Pear Street and the definition of mid-segment to find the length of Cherry Street, so the full length, not just part of it. Then add the distances along your route. All right, so first step we have to solve the problem. We've got the length of Pear Street is half the length of Plum Street, because Pear Street represents our mid-segment. So if Pear Street is 1.4 miles, then half of 1.4 miles is going to be 0.7 miles. So the length of Pear Street is 0.7 miles. Second, we can figure out the length of Cherry Street, because Cherry Street, Pear Street hits Cherry at the mid-segment, which makes this other part of Cherry Street that's unknown the same length as what is known, which is 1.3. So we take twice that length and we get 2.6 miles for the full length of Cherry Street. So now we have the missing links. Now we just need to add up all of the distances along the route. So we've got the 2.6, which is the full length of Cherry Street. And then we have the 1.4, which is the distance along Plum Street. And then we have half the length of Peach Street plus the 0.7 that is Peach Street, plus the 1.3 that we know along Cherry Street, which gets us a total of 7.125 miles. So you jog about 7 miles. And then always look back just to use compatible numbers to check that your answer is reasonable. So our total distance, we got 2.6, 1.4, half of 2.25, 0.7, 1.3, which comes out to be approximately 2.5, plus the 1.5, plus the 1, plus the 0.5, plus the 1.5, which comes out to be approximately 7. So it all checks out. And that's all for the triangle midsegment theorem. We'll practice our theorem in class tomorrow. Bring your notes.